Welcome back, all my aspiring mathematicians. Today, I am going to dive into the topic of simplifying radicals. There are four types of operations that can be done in order to simplify radicals. And the four types of operations are adding, subtracting, multiplying, and dividing. Now, today's lesson is simply about how to add and subtract radicals. When you see a radical sign, there are four components that you need to be able to identify easily. The first one is the coefficient, which is the a, which is usually the number that is in front of the radical sign. Next, you need to be able to identify the index. Now, what you also need to know is that if you have an index of 2, you're not going to see it. It is going to be invisible, just like normally an invisible 1 that is in front of a variable or even a radical symbol for the coefficient. So you will usually see an index of 3 or greater, but you're not going to see an index of 2 because simply saying that the index of 2 is telling you that you're to find the square root of that number. With the index of 3, you are going to be asked to find the cube root of that number. Not only will you see the coefficient, but you will also see the index. And the index is telling you if you are taking the square root or if you are taking the cube root of the number. Now you will also see the radicand. The radicand is that number, or it could be a variable and a number underneath the radical sign. And yes, the fourth one is the radical sign. Let's first talk about the radical sign. A radical sign indicates that a root of a radicand is to be found. A root is a factor of the radicand which is multiplied by itself a given number of times to produce the number underneath the radical sign. A radical sign without an index is simply telling you that you are going to find the square root of a number. And a radical sign with an index of 3 is simply telling you that you need to find the cube root of that radicand. The radical symbol, which we call it the square root symbol, which doesn't have an index, is simply telling you that you need to multiply the answer by itself to get the radicand. A radical sign with an index of 3 is simply telling you that you need to multiply that answer 3 times to get the radicand. Now, before we get started, we also need to note that the number underneath the radical sign, which is known as the radicand, is either going to be a perfect square or a non-perfect square. And if it is a perfect square, then that will just simply equate to a number, a simple number. If it is a non-perfect square, you can either break it down into a perfect square and a non-perfect square, except for an instance where it is a prime number. And if it is a prime number, obviously the only two factors are 1 and itself. So you need to note that. And then with that said, that prime number underneath the radical symbol cannot be further broken down. So just remember that there are 3 things that you should look for. One is the perfect square that is underneath the radical sign and the non-perfect square underneath the radical sign, and you have to break down the non-perfect square into a perfect square and a non-perfect square. For example, the square root of 121 is 11 because 11 times 11 is going to give you 121, which is the radicand that is underneath that radical sign. For example, the cube root of 27 is 3, and that is because you are multiplying 3 times. 3 times 3 times 3 is going to be 27. Or you can say 3 times 3 is 9, and 9 times 3 is going to give you 27. So before we get started, I want to tell you the steps that you need to take when you are simplifying radicals, and in particular when you're adding and subtracting radicals. So the first step is that you're going to simplify all terms. The second step is that you are going to add or subtract the coefficient of the like radicands, and only of the like radicands. You cannot do radical 2 subtract radical 3 and tell me it's radical 5. No, you cannot do that because 3 and 2 are two different radicands. They must be the same. So you can put together radicand 2 and radicand 2 or radicand 3 and radicand 3. Don't make that mistake. The third step is that you're going to keep the radicand with the answer for the coefficient that you got from step number 2. So without further ado, let's get into our first example of how to add and subtract radicals. So our first example is to subtract radical 32 and the radical 8. And you will notice here off the top that none of these two radicals that are given have a perfect square underneath the radicals. So you have to treat these and break them down so you get a perfect square and a non-perfect square. So with the first one, which is square root of 32, because there's no index number here, you're going to break down this, and we always find the highest perfect square that we can use that as a factor of 32, and that would be 16 and 2. Yes, you could have used 8 and 4, but the reason that you go for the highest one is then you would have to break down the 8 and the 4. So another way you could have done it, if you could have done square root of 4 and square root of 8, but then you have to further break this down again. So that's why I simply went ahead and chose to use square root of 16 and square root of 2. So I just have to break this down once. So square root of 16 is going to give you 4. Square root of 2 is simply going to be 2. You're going to have this right here, and then you're going to bring down your minus sign, and you need to break this down also. And when you break that down, you're going to end up with now square root of 4 and square root of 2 here. Square root of 4 is going to be 2, and you have the radical 2 also. Now, because you notice that you have the same radicand in both terms, then what you can do, take that out, leave your coefficient, right, inside the parentheses, and you will follow through and simply do what's inside the parentheses first, follow through with the order of operation, and you can go back and watch my video on order of operation to help you. And this you will have 2. Do not leave your answer as this. Your final answer now is going to be 2 radical 2. And I always tell my students, box your answer or put a cloud around your answer. Now let's go back to if you did not choose the highest perfect square as one of your factors and you chose to use square root of 4 and square root of 8. And I'm going to show you that you have more steps to deal with when you do that. So square root of 4 is simply going to be 2. Square root of 8 you have to break down to square root of 4 and also square root of 2. You notice here this will give you 2, and now what you have to do, you're going to bring this one down. So you will have 2 times 2, which is going to be 4, and you bring down your radical 2 right here. Same as this, just less steps over here as opposed to on this side. So it's up to you if you want to take the longer route, but I'll suggest learn to shoot for the highest perfect square that you can simplify. But if you're not that strong in maths yet, until you're able to identify the highest factor that is a perfect square, then break it down simply, okay? So let's get into the next example on how to subtract or add radicals. So this example is saying, what is the sum of radical 75 and radical 12? You will notice that They're asking for sum here, and they're asking for two radicals that are non-perfect squares. So we have to break them down. So we're going to do radical 75 plus radical 12, because sum means that we're going to add, and that is the operation we're doing now. First example, I did subtract. Now I'm doing addition. Okay, so break this down. Factors of 75 with a perfect square is 25 and 3. So I'm breaking this down into two radicals, one perfect square, one a non-perfect square, and I'm going to do the same thing for 12. So for 12, I could break it down into 4 and 3. So radical 4 and radical 3. Square root of 25 is going to be 5, and you bring down the radical 3 there. You bring it down, and plus this is going to give you 2. Square root of 4 is 2, and you also bring down your radical 3. You will notice that the radicand are the same in both terms. So you will take that out, and you will now write the coefficient inside the parentheses. So now you will have radical 3, open parentheses, 5 plus 2 is 7. But don't leave your answers this. You're going to write 7 radical 3, and that is going to be your final answer. Not everything in math is straightforward. The wording at times throws some of you students off. So I'm going to show you an example now where the wording might want to throw you off, but if you are thinking logically, then you will be able to do it properly and achieve the correct answer. So let's get into that next example. This example states that you're going to subtract 3 radical 18 from 10 radical 2. So notice the wording, subtract this from this. Some students will want to look at this problem, read it, and start the problem like this. This is incorrect. No, you can't do that because you're subtracting 3 radical 18 from 10 radical 2, and this is where students will make mistakes. Some of you, not all, but I still have to point this out, okay? Don't get caught by their little tricks and you will get your answer incorrectly. You are going to set it up where you have first 10 radical 2 subtract 3 radical 18. This is a proper way of setting up this type of problem, okay? So you have now 10 radical 2. You cannot simplify this any further. It still remains the same. And you can simplify the radical 18 here. So you will normally have that type of problem. So you can do this and simplify this. Highest perfect square is radical 9, and the next one is radical 2. All right? So we have 10 radical 2 subtract. Radical 9 is going to give you 3. So you have 3 times 3 here, and you have the radical 2. So this now is going to be 10 radical 2 minus 3 times 3 is 9 radical 2. Radical 2, right, are common in both terms. So you're going to take that out. That is going to be the number that you're going to put outside, radical 2, and then you have 10 minus 9 inside, which is going to be coefficient. Now you end up with radical 2 parentheses 1. Now, we are going to treat this just the same way as how we would treat 1 in front of any variable. Let it be invisible. So your final answer is simply going to be radical 2. Do not write 1 radical 2. This is your final answer. Don't write it this way. The 1 must be invisible, just like when you are writing a variable. You don't write 1x or 1y. No, you simply write x or you simply write y. All right, so just bear that in mind. So let's get into our last and final example. We are going to simplify radical 63 plus radical 27 subtract radical 48. And if you notice here, none of these are perfect squares. So that simply means that we now have to break down each of these into a perfect square and a non-perfect square where possible. So let's tackle the first one. We have radical 63 is going to be broken down into radical 9 and radical 7, because 9 times 7 will give you 63. 9 is a perfect square, and square root of 7 is a non-perfect square. And radical 27, we are going to break it down as a perfect square, which is 9, and 9 3 is 27, so you have radical 3 as a non-perfect square here. And square root of 48, let's break this down. Perfect square, we could have chose 4 and 12, but that is not the highest perfect square. We are going to choose for radical 16 and radical 3. So let's put this together. Radical 9 is going to be 3 when you simplify it. So you have 3 radical 7 here, plus radical 9 is going to be again 3 radical 3, and subtract radical 16 is going to be 4, or this, you can say square root of 16 is 4, and this is what we have. So you will notice that only these two terms have the same radicand. Radicand 7 is different here. So we're going to keep the 3 radical 7 plus, you can do this easily here. You don't even have to take out the radical 3 if you're versed in math. You can go ahead and note that because the radicands and 3 minus 4 is going to be negative 1, so you have to get rid of this plus, and you're going to have minus 1 here, but don't leave this as your answer. You are now going to write this without the 1, make it invisible, but not only that, 3 comes before 7, so you're going to write your final answer as negative radical 3 plus 3 radical 7. And this would be your final answer. Okay? So there is a difference there. So do not write negative 1 radical 3 plus 3 radical 7, nor don't write it as 3 radical 7 minus radical 3. This is a proper way to write it when you are dealing with radicals. So if you need more help on simplifying radicals, you can also go back and watch my video on how to multiply and divide radicals, and that will help you tremendously. So in conclusion, now that you know how to add and subtract radicals, I hope you will adhere to all these steps. Simplify your non-perfect square that you have underneath that radical to whether it's going to be the highest perfect square with another non-perfect square, or if you can't remember the highest perfect square, then shoot for a lower one, but do note that you're going to have more steps to take when you do that. So I hope that this video has helped you tremendously and you have learned something in this lesson today, and you will take it with you whenever you are given any topic on how to simplify radicals, especially adding and subtracting radicals. If you have not yet subscribed to my channel, what are you waiting for? Go ahead and hit that subscribe button. And if you like what you see, hit that like button. Don't keep this video to yourself. Share it with others around the world so they too can be successful on simplifying radicals and be great at math. Thank you for watching and see you soon on the next video to come. Bye now. Cheers.